Hi. Previously, we have solved this N4 displacement problem in MSC Nastran. So basically, we have applied this 5 mm N4 displacement in Z direction. So you can see the results here. It is deforming in Z. But so uh, to achieve this, what we have done here is we have just applied a fixed. We have constrained 1, 2, 3 here, and we have applied an enforced displacement in 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 third DOF. So, but if I want to like displace it in this direction, which is 45 degrees to z-axis, how can I achieve it? So, for this purpose, I need to create one system here. So, to create a system here, uh, firstly we will just clear this temp nodes, and then I'll just go on here to move here and select this node, and I'll just duplicate this node, and then I need a system here in this 45 degrees. So what I can do here is I can just rotate it to minus 135 degrees, and then I can just go on here and drag to a certain height. It can be arbitrary. You can even drag it to 10 mm or 1 mm. It doesn't matter. And then we have got 2 points here. Now I'll go to just model here and select systems. And by the way, you can uh, create various types of systems like, sorry, yeah. So I'll just click on this origin node as this, and now it will ask me which system I want to create. I'll just stick to this rectangular system, and then it will ask me uh, which plane I want it. I want the z-axis as my primary axis. So this z-axis, I will just pick it here as this one. And I don't care about the other axes, as if this is my of least concern. Just I want a enforced displacement in this direction, so I will stick. I only care about the z-axis. Just create this, and you can see this. It is in 45 degrees with this z-axis, negative of this z-axis. And now one more thing we need to do here is once after creating the system, we need to assign this node to this system. And assigning this node, you need to have two concepts clear. One is called as a reference coordinate system of a node, and one is called a displacement coordinate system of a node. So you can define this system, you can select this system, and you can assign this node. But which coordinate system you need to use? You can use it. You can set a reference coordinate system for this node. You can select a displacement coordinate system for this node, or you can set both. So what is the meaning of this reference? Reference means any node. How is it defined? So you know, like node is defined by x, y, and z coordinate. And if you don't set this reference system, automatically MSC Nastran assumes it is in global coordinate system. But if you set this reference, it will assume like now you have uh, it will write that node in that coordinate system of this. But the position of node will be same in FEA. So for mostly this reference option is not used for most of the cases, as uh, because most of the analysis you will be doing is isotropic and there is no directional properties needed. Means whatever properties you are giving is same in all directions. So the use of this reference is no longer reference node is no longer needed. It is mostly used if you want, like if you have put a nugget for a spot and you want different properties in as per the coordinate system, then you can use this reference coordinate system for a particular node. For this case also you can use it, but that will be but the results won't vary with this reference coordinate system for this analysis. Displacement coordinate system means identification of the coordinate system in which displacement, degrees of freedom or constraint, and solution vectors are defined at that grid point. Meaning like uh, what will be the, if I define this as a displacement, that means whatever the displacement constraint I will be giving, that will be automatically be in this coordinate system. So that is the meaning of displacement, and whatever the results it will give will automatically be in this coordinate system. That is the primary reason of setting a node to a system and set this as a displacement coordinate system. So I will just clicking on this. Now, if you see here, this enforced node will automatically be seeing 3, but you have defined this node in this coordinate system. So that means this uh, 5 mm displacement will be in this direction, in that direction, in local Z. Now I will export this deck and try to solve it. So I will just go on here and export this. Just click on export and I will try to solve it and we will see the result once it is solved. So once you open the OP2 file, we can see in the animation it is deforming in the positive y direction. But we have defined the N4 displacement in this direction. So why so? So just we can firstly we will plot some of the displacement and we can able to understand why. So firstly we can just plot the magnitude. Uh, so you can see that this is 7 mm of displacement in the spider center. So but we have applied 5 mm in the local z direction. Then we can, by the way, this is resolved in global XYZ coordinates. So then we can check the local X, it is almost 0. Local Y, sorry, local, uh, this is global X and this is global Y. Global Y is 7 mm. And if you check the global Z also, it will be 0. That means whatever we are applying displacing in 5 mm this here, it is so stiff in this direction and it is flexible in the bend direction, in the bending. So it is deforming like this. Now we need to check whether we have applied 5 mm correctly, whether the software is understanding whatever the loads we have applied. So we can just go to here, user selected. We can select this that and we can just select this system and click on apply. Sorry. Click on apply. So you can see that this system ID is seen now and if you set apply, 1 second. Yeah. Now you can set this as 5 mm exactly, whatever the value you have applied in the local Z direction. So this is how you can apply the enforced displacement at any angle or any coordinate system in MSC Nastran. Uh, so you can also download the PDF file from the attachment if you want. And thank you. Have a great day. Bye.